Saxon Advanced Algebra Lesson 71. Boy, for a minute there, I thought my voice had cut out like a bad speaker. But here I am in all of my glory to talk to you about Lesson 71, the ellipse. Oh, and I should tell you that after this name in the title, it has a 1 in parentheses like that. I think that's a pretty clear indication that we're going to be coming back to our friend the ellipse again after this lesson. Don't you? Okay, an ellipse, when you were younger, went by the more unassuming name of oval. An ellipse is an oval, okay? And it's designed, or it comes out, remember our conic section? That shape that we get when we take the marker and we spin it, right? We take a point, which is between my fingers, and a line, and we hold the line at the point, and then we rotate it, and it makes this shape that we call a conic section. It's three-dimensional, but you have to imagine. And then we make a bunch of them out of butter, and then we take hot knives and we slice them to get certain shapes, right? So if you slice straight through and then take that and look at it, what you will get is a perfect circle, right? But if you take another one, and that's why I always have a bunch of them in my freezer, because once you start slicing these butter sculptures, you just want to do more and more. If we slice it at an angle, then when we look at it, what we get is an ellipse. So that's what we're doing today. This is our friend for today. We've talked about circles plenty lately, and we'll talk about them more. But today we're going to focus on the ellipse. Now, another cool way to think about an ellipse. Okay, with a circle, if you put a point down in the middle, imagine that's a thumbtack, and then take a piece of string, and then put your finger, or not your finger, your pencil in the end of it, draw a loop, for heaven's sake, and you go around, what you get is a circle, right? So thumbtack string. Now, for this one, instead of having one center, we're going to have two centers. And what we're going to do is have a string attached to it, and our pencil we'll put right in there. That's the pencil, all right? Pretend with me. Now, if we pull around on this, we're going to get not a perfect circle, but we're going to get a shape more or less than that, like that, okay? So we call these two the focal points, right? And the string will have two distances, and those distances will change as we move the pencil around, right, to fill the circle, but they will always add up to the same total. Okay, we don't really need to know a whole lot about that. In any ellipse, there is a major axis and a minor axis. Because the ellipse can be oriented either way. So it could be graphed like that, or it could be graphed like that. Pretend these are perfect, okay? What we are not going to deal with is any sort of tipped business, right? Obviously, you could orient these in lots of wonky ways. We're not going to deal with that. We're going to deal with perfectly squared off ellipses. And this is the equation of the ellipse. And it's subtly different. Watch and see. For this one, that is the formula. And for this one, this is the formula. Subtle difference. Notice that on this one, the A is under the X, the B is under the Y. And here it reverses. B is under the X and A is under the Y. Here's why that is. A is always associated with the major axis. A goes with the major axis. And I don't think I spelled this out, but the major axis is the long one. The minor axis is the short one. Okay, so here, this is the x-axis, and that's the longer one. So he gets the A as his denominator. And over here, the y-axis carries the long part of the ellipse. So that means the A is associated with the y value. Okay, so that's how you can tell. The A always goes with the major, which makes sense because major has an A in it. Oh, I love when John makes it. Well, John didn't do it, but I love when the world of math makes life easy on us. Okay, let's take a look at a little bit more detail of how we graph these, and then we have two simple problems as to how to graph them. This is actually, I think, quite a fun lesson. All right, we're going to draw this picture with a major, it's a horizontal ellipsis. Okay, horizontal because it's oriented toward the horizon. Pretend it's perfect, all right? This distance we call B. It's half the width. This distance we call A. It's half the long side, right? We can imagine points in here. We don't know exactly where they are because we haven't figured them out mathematically. But these are those two focus points I talked about in that other picture. That's basically where we thumbtack the string down and then put our finger in it, or our pencil in it, and draw, right? We're going to get into a later lesson. We're going to calculate those. But right now, we're not. Okay. And so, if this length, and we're assuming this is oriented at the origin, this point would be 0b, and this point down here, that's this point. This point would be 0, negative b. Makes sense? Because b is this distance, and it's the same on either side. Accordingly, this point here is a0, and this point here is negative a0. Make sense? And then again, our formula for this one would be x squared. X is the axis that's longer, so that gets the a. Okay, so what this does is it allows us to take this information and graph. Or it allows us to take the graph and figure it out, depending on what John gives us numbers for. So let's see what he's got up his sleeves in example 71.1. Graph the ellipse. X squared over 25 plus y squared over 9 equals 1. Okay, this looks really good. It looks set up properly. We look and see what's bigger, A or B. It looks like A is this way, so it's going to be oriented this way. Okay, that's cool. Let's figure out what is A and what is B. Well, if 25 equals A squared, then A must be 5. And if B squared is 9, then B must be 3. So far, so good, right? So now, all I need to do is draw my ellipse. I have a problem of making this side a little bit bigger. Oh well, you can imagine, okay? So A is this long side. I can measure it on either side because they're the same, despite my picture's suggestion. So this point would be 5, 0. And then I know over here, this is also 5 units long. So this is going to be negative 5, 0. All right. And then I know that this dimension is 3, as is this one. So this point is going to be 0, positive 3. And this point down here is 0, negative 3. We don't know the focal points. In this lesson, this is a completed answer. We are done. All right. And then let me flip my page because the next problem, we only have one more problem. We're done. This is it. This is the correct answer. I could put, I don't want to clutter it up. I could put an X here and a Y there just to name my axes, but I don't want to clutter up my point values. That's more important. All right, 71.2. Make sure you can see me. All right, write the equation in standard form and graph the ellipse. Okay, we look at this and go, dude, no, that is not in the right form. That looks hideous. So we're gonna have to do something about that. And my ink is bleeding through my pages, which drives me crazy. So I'm gonna do something about that. Okay. Oh, wait. Oh no, that's right. I thought I put it 2 pages down, but I didn't. We're good. Okay, so what we have to do is we have to somehow give these denominators and we have to turn that into a 1. As it turns out, turning this into a 1 is the right place to start. So we're gonna divide everybody by 15. Okay? So now we can cancel. That goes to 1. That's beautiful. 15 and 5, that tells us x squared over 3. Ew, that's not a perfect square, right? All right. And then y squared, 2 over 15, that's 7.5, right? I'm gonna write that in decimal form. That is not a perfect square either. So I can see the honeymoon is over and John is making things a little bit crazy for us now, right? So I can see that our value for A, that must be this one, right? Because this number is bigger. So I know that this time I have the form of x squared over b squared plus y squared over a squared, right? Because A always goes with the major axis, and the major axis is whichever one's bigger, and clearly 7.5 is bigger than 3. Now I want the, the square root of A is going to be the square root of 7.5. That's all it's going to be. And then B is the square root of 3. Okay, just to help my brain understand, I understand that the square root of 4 is 2 and the square root of 9 is 3. So this is going to be 2 plus 2 point something, right? And this is 1 point something. All right, so that gives me an idea roughly of how this is going to look. And in fact, what I can do is I can use my calculator to simplify these. And John does do that in the solution, so you can do that too. Use your calculator, enter 7.5, and then push the button that has a square root sign with a little 2 there and an x. Enter the number first, then hit the function key, and you'll get 2.74. And then for 3, you'll get 1.73. Okay, so now we have actual values that we can graph. Now we're ready to graph it. Before I draw the picture, I double check to see which way my orientation goes. This is an up and down. This is a vertical. So it's going to be like this. I mean, you get it. This is A. So that tells me that this value up here is 0, 2.74. Remember, just be careful about where the 0 goes in these points. This is on the y-axis, so that means the x value is 0, but the y is 2.74. And then down here, this would be 0 minus 2.74. Okay, that's my A, and then this is my B value, which is 1.73. So this point is 1.730, and this point is negative 1.730. Just looking to make sure that I did that correctly. Yep, positive, negative, positive, negative. John doesn't even mark the A and B in these, but I went ahead and put those in. Okay, and notice in this point, we're not even drawing in those focal points because we're gonna learn later how to calculate those, but this is just the first lesson, as you recall, on ellipses. So feel smart and know that we're going to add to this in the future. Okay, that's all. Thank you. Goodbye.